Hello everyone, welcome to ACE Engineering College YouTube live sessions. In these sessions, we are going to discuss about the previous year's questions asked in the end semester exams. These videos are useful for each and every engineering student. So I request all the engineering students to see full videos and perform well in their respective examinations. Now, coming to today's session, we are going to start a new series of explanation about the previous year's questions asked in the subject Thermal Engineering 1. My name is Abinay. I am the faculty of ACE Engineering College and I am going to deal with this Thermal Engineering 1 subject. So, what is meant by thermal engineering? Thermal engineering is nothing but the application of thermodynamic concepts to the systems so that by proper understanding of the system we can analyze the system and we can able to estimate the performance of a particular system. Not only estimating the performance, but also we can able to know the methods to improve the performance of a system. That is what the thermal engineering means. Thermal engineering basically is of two parts: thermal engineering part 1 and part 2. Part 1 deals with the IC engines, compressors and the gas turbines. IC engines, compressors and gas turbines, whereas thermal engineering 2 deals with the steam power plants, jet propulsions and the rockets. So these are the various systems present in the thermal engineering 1 and 2. Now whatever the system may be, what we have to do is we have to apply the thermodynamic concepts to the systems. Then by proper understanding of the system, we can analyze the system to estimate the performance of a particular system. Now what are the different various contents present in this thermal engineering 1 subject? There are 5 units. Unit 1 deals with the IC engines. Unit 2 deals with the IC engines. Unit 2 deals with the combustion in SI engine and CI engine. Unit 3 deals with the performance of testing of the IC engine, along with that reciprocating compressors. Unit 4 deals with the rotary and dynamic compressors. Unit 5 deals with the gas turbines. Now here in the thermal engineering 1, we are discussing about 3 systems. One is IC engines, second one is the compressors, third one is the gas turbines. Now from all these units, what type of questions are asked in the examination, whether it is a theoretical question or a numerical question? When we see the previous examination question papers, we can say that from the unit 1 and the unit 2, we are getting only a theory based questions, whereas unit 3, unit 4, unit 5, from these 3 units, along with theory, we are getting a numerical based questions. So from the unit 1 and unit 2, we will be getting a theory questions. Unit 3, unit 4, unit 5, we will be getting theory based questions. Now let us see the applications of the IC engines, gas turbines and the compressors. First, let us start with the IC engines. We all know that the IC engines have used in our daily lives for the various purposes, like automobiles, like in buses, cars, trucks, all the ways we will be using these automobiles for the automobile propulsion. And not only in the automobiles, we will be using in the aircrafts, in the motorboats, not only in the big size engines, big side applications. We can also use these IC engines for the purpose of lawn movers, that is a small size machines used for some work, the lawn movers, and also for the generators. So these are the some applications of the IC engines. Next, comes to the application of the compressors. Where do we use these compressors? Now, what is the function of compressor? To increase the pressure of the air. Now, where there is a requirement of compressed air, where there is a requirement of compressed air, at that places we will be employing these compressors. For example, in the roads, for the drilling of the roads, we will be using the drilling machines. The drilling machines will be operated with the help of a high pressurized air. For that, creating the high pressurized air, we will be employing a compressor there. So that tool, drilling machine, is called as a pneumatic tool. It's a pneumatic tool. Not only for that purpose, in the industries, for the cleaning purpose, we will be using the air blast for the cleaning, for the cleaning purpose. And in industries, for the manufacturing of the plastic products, we will be using these compressors. And in the automobiles, for the tire inflation, that is, in the tires we have to maintain the high pressurized air, so we have to send the air. For that purpose, we will be using these compressors. And for the automobile body spray painting purpose, we will be using these compressors. And along with that, in the mines, when the mines are digged, the air present in the mines will be very less. So we have to supply the high pressurized air so that everyone can breathe. So in the mine tunnels also, we will be using these compressors. These are only some applications. Now coming to the application of the gas turbines. These gas turbines are used mainly for the aviation purpose. That is, in the aircrafts, in the rockets, we will be using this gas turbine setups. And for the marine propulsion, along with that, it is also used to generate the power, and also it is used in the oil and gas industries. Now these are what some applications of the systems what we see in the thermal engineering 1 subject. Next, coming to our main topic, that is IC engines. Thermal engineering 1 unit 1 is IC engines. Now let us see what are the various previous years questions are asked in the thermal engineering 1 IC engine topic. These are only some questions. Now first one, if you see, what is IC engine? And how do we classify it? And with a sketch, we have to explain the working of four-stroke diesel engine. And also there is another question, working of spark ignition engine with a sketch. And the next question was, compare the differences between the spark ignition engine and also the compression ignition engine. The next question was the differences between four-stroke engine and the two-stroke engine. These are some questions which are asked in the previous year's question papers from the topic of IC engines. Now let us start our topic, that is IC engines. So basically, what is an engine? Engine is a device which converts the chemical energy into the mechanical energy. Now what is this chemical energy and how do we convert that chemical energy into mechanical energy? Chemical energy is nothing but the fuel. Like petrol, diesel, all CNGs, all these are fuels. The fuel is combusted. That means burned. Because of the combustion, it releases the heat energy. And that heat energy is converted into the mechanical energy by means of a system. So here, engine is a device which converts the chemical energy into mechanical energy. That means the fuel is combusted, which releases the heat energy, and the heat energy is used to convert into mechanical energy by means of a system, and that system is IC engine here. Then what is this internal combustion engine? Internal combustion engine means the combustion of fuel takes place internally. The combustion of fuel takes place inside the cylinder. So which releases the heat energy, and that heat energy is used to move the piston. That heat energy is used to move the piston, which will be act as a driving energy for the internal combustion engine. That is what internal combustion engine. Now examples of that internal combustion engine is, we all know in automobiles, petrol engines and diesel engines all are internal combustion engine. Now let's see what are the main parts of the internal combustion engine. In this figure we can see that the main important part is the piston. The main important part is the piston. The piston will be having a reciprocatory motion. The piston will be having a reciprocatory motion. That means piston will be reciprocated inside the cylinder, and that piston is connected with a connecting rod here. This is the connecting rod. Piston is connected with a connecting rod. This connecting rod will be having two ends. One is small end, another is the big end. The small end is connected with the piston, that is called the gudgeon pin. And the big end is connected with a crank here. Big end is connected with a crank with the help of a big end bearing. So connecting rod will be having two ends. Small end is connected with a piston with a gudgeon pin. Big end is connected with a crank with the help of a big end bearing. Now this reciprocatory motion is converted into the rotary motion of the crankshaft. The rotary motion of the crankshaft with the help of the connecting rod. Now in this animation you can see how the reciprocatory motion is converted into a rotary motion of a crankshaft. Now over the cylinder, the piston and connecting rod are placed inside the cylinder, and over the cylinder there will be a cylinder head. This cylinder head is fixed with two valves. One is inlet valve, another is the exhaust valve. Inlet valve, another is the exhaust valve. Now what is the purpose of this inlet valve and the exhaust valve is, now what is our purpose of the IC engine? The fuel has to be combusted and the heat energy has to be converted into the mechanical energy. That means the fuel has to be entered into the engine, then it has to be combusted. So for the entry of the charge into the cylinder, we will be using the inlet valve. So through the inlet valve, the air fuel mixture or the charge will enter into the combustion chamber or in the cylinder. After combustion, the gases has to be escaped outside the engine. So for that purpose, this exhaust valve, through the exhaust valve, the gases are exhausted out. Now how this actuation, the opening and the closing of the inlet valve and the exhaust valve, how it takes place means with the help of a camshaft. Now see here, this valve is attached with a rocker arm here, and the rocker arm is fixed with a push rod which is placed on the camshaft. This camshaft and the crankshaft both are joined with the help of a timing gear arrangement. Now when this camshaft is rotated, it will push the push rod, and push rod will actuate the valves so that the valves are opened and closed. So that is a valve actuating mechanism here. Now one more important point which is present here is the piston rings. What is the purpose of piston rings here? The piston rings of two types. What are those? The first one is compression rings. Compression rings and the second one is oil rings. So these two rings are placed over the piston here. So on the piston. So what is the purpose of the compression ring is to maintain a tight seal between the piston and the cylinder, because whenever the heat energy is released, if there is a gap between the piston and the cylinder, that heat energy will be escaped into the crankcase area. So that has to be stopped. That can be possible by maintaining a tight seal between the piston and the cylinder. Then what about the oil ring? What is the purpose of oil rings here? Is when the piston is reciprocating inside the cylinder, because of the friction, the wear and tear of the parts takes place. Now it should not be done like that. So we have to lubricate it continuously. So the lubricating oil passes through the oil rings, and there will be a smooth operation takes place inside the engine. Now these are the main parts of the engine. Now let's see a small animation video so that we can get a clear cut idea here. Here we can see that the piston is reciprocating, and it is connecting rod is arranged with the crankshaft. So the reciprocating motion of piston is converted into the crankshaft, and crankshaft is connected with the camshaft here with the help of a chain drive, and the camshaft is operating the inlet and exhaust valve. So in this way all the parts of the engine are arranged. Now let's see the important terms used in the IC engine, and we are saying here that inside the cylinder there will be a piston and the connecting rod. Now the diameter of the cylinder is called bore. The diameter of the cylinder is called bore, and that bore is also called as cylinder bore. And when the piston is reciprocating inside the cylinder, now what are in between which points it will be reciprocating? There will be dead centers. In between the dead centers only piston will be reciprocating. That dead center is top dead center and the bottom dead center, TDC and BDC. Between those two dead centers only piston tends to reciprocate, and the length between the TDC and BDC is called stroke length. Length between TDC and BDC is called stroke length, and the volume in between the TDC and BDC is called swept volume, or it is also called as stroke volume. Stroke volume, swept volume, or the stroke volume. Clearance volume is here you can see that from the TDC point to the cylinder head there will be a small gap. That small gap volume is called as clearance volume. And the most important term what we use in the IC engines is the compression ratio. What is this compression ratio is? This compression ratio is indicated by a term small r. It is a ratio of total volume by clearance volume. Total volume by clearance volume. That is, what is this total volume here? Total volume is the clearance volume plus the stroke volume. So total volume is clearance volume plus stroke volume by clearance volume. So compression ratio is equals to clearance volume plus stroke volume by clearance volume. That is total volume by clearance volume is the formula for the compression ratio. And now coming to the classification of the IC engines. Now here the IC engines are classified based on so many factors. The first one is the ignition. What is mean by ignition? Ignition is nothing but the initiation of the combustion. Ignition is nothing but initiation of the combustion. So here, based on the initiation, we are having spark ignition engine and a compression ignition engine. Spark ignition engine and a compression ignition engine. What is spark ignition engine? For the igniting of the charge, if we use any external aid like spark plug, spark plug, that is spark ignition engine, and that is based on the Otto cycle, and the second one is compression ignition engine. What is compression ignition engine is the ignition of the charge takes place by itself, that is auto ignition happens. In the case of compression ignition auto ignition happens in the case of compression ignition engines, that is the based on the diesel cycle, and the other factor is according to the working cycle. The first one is two-stroke engine. What is this two-stroke engine is? Now what is our purpose? Our purpose is to convert the fuel into mechanical energy. After that, the gases which are released because of the combustion, that has to be escaped out of the engine. Now all this process completes in two strokes. What is meant by stroke? Just now we have seen stroke is nothing but a travel of a piston. If the piston travels one time in between the TDC and BDC, it is called stroke. So if the piston moves two times, two travels of the piston, and the entire operation will be done, entire process will be done, then it is called two-stroke engine. If the entire process, that is entry of the fuel, combustion of the fuel, and generating the heat energy, getting the driving mechanical power, then exhausting the gases, if all these processes have been completed in 4 strokes, that means piston will move 4 times inside the cylinder in between TDC and BDC, that is called 4-stroke engine. Now according to the cooling, we are having air cooling and also liquid cooling. So what is meant by air cooling is, if the engine capacity is less, means if the engine is developing less heat energy, small engines will be developing less heat energy, for that purpose we will be employing this air cooling. So how this air cooling is employed? By means of placing fins. By means of placing the fins, we will be having this air cooling. So in the air cooling, the fins are placed over the circumference of the cylinder to have the cooling purpose. Whereas if the engine is developing more heat, that means the more heat has to be taken off from the cylinder for the cooling purpose. That is called, in that case we will be using liquid cooling. In this case, what we will be using? We will be using the radiators. That is heat exchangers. We will be using the radiators. Right? That is according to the cooling. Next one is according to the fueling. Fueling is what type of fuel we are using. Suppose if an engine is using the gasoline, or the petrol, those engines are called as the spark ignition engine, and the engines are using the diesel as a fuel. Then it is a compression ignition engine. Not only that, according to the number of cylinders also, the engines are classified. The first one is single cylinder engine. That means it will have only a single cylinder, piston and connecting rod and a crankshaft. Whereas double cylinder engine, in double cylinder means it will have the 2 cylinders, 2 piston and the connecting rods. And multi-cylinder engine, that means there will be more than 2 cylinders in the engine. And according to the cylinder arrangement, we are having these types of engines here. The first one is inline engine, inline vertical engine. What is this inline vertical engine is? If the cylinders are placed one after the other in a line manner, that is inline engine. What is this vertical means? If the piston reciprocates in a vertical direction, that is inline vertical engine. And the next one is V-type engine. V-type engine. What is this V-type engine is, there will be a single crankshaft. On the single crankshaft, we will attach two banks of the cylinder, so that we can produce more power, and the angle between that V or the two connecting rods is approximately 45 degrees. And the next one is horizontal engine. What is this horizontal engine is? If the piston reciprocates horizontally, then we call it as horizontal engine. And the next one is the opposed cylinder engine. So what is this opposed cylinder engine is? On a single crankshaft, the cylinders are placed opposite to each other. On a single crankshaft, the cylinders are placed opposite to each other. That is opposed cylinder engine. The last one is the radial engine. That means on a crankshaft, the cylinders pistons are arranged in a radial manner. The cylinders pistons are arranged in a radial manner. That is called radial engine. These radial engines are also called as the star engines. Now before the much uses of the gas turbines in aircrafts, these radial engines were used. Now coming to the concept of IC engine working process. Now whatever the IC engine is, these are the sequence of operations has to be followed. What are those sequence? First one is the suction. So here the suction means suction. The second one is the compression. Third is the expansion. Fourth is the exhaust. So suction, compression, expansion and exhaust. So this is a sequence of processes is carried out in the working of IC engine. The other name of the suction is also called as intake process, or the expansion is also called as power, or it is also called as combustion. So expansion stroke or power stroke or a combustion stroke, all are same. Now let's coming to the working of 4-stroke spark ignition engine. 4-stroke spark ignition engine. So as I said, here the sequence of operation is what? First suction, then compression, then expansion, then exhaust. So first we'll start with the intake process, that is the suction process. So initially in this spark ignition engine, the piston will be at TDC point. The piston will be at here TDC point. So when the piston starts moving from TDC to BDC, what happens? This inlet valve is opened. And the air and fuel mixture through the inlet valve, it will enter into the cylinder. Here. So air plus fuel mixture will be entered into the cylinder. During which process? During the intake process or the suction process. At that time, what is the travel? In which direction the piston is traveling? It is traveling from TDC to BDC. And what about the exhaust valve? It is closed. Now, when the piston reaches the BDC point, the intake valve will be closed. Now, it completes the suction or the intake process. Next comes with the compression process. Now already the intake valve is closed, right? Now, and exhaust valve is also closed. Now the piston will be moving from BDC to TDC. When it is moving from BDC to TDC, the volume tends to decrease, which increases the pressure and temperature of the charge present here, which increases the temperature and pressure will be increasing of the charge. Now when the piston reaches the TDC point, a small spark is created with the help of a spark plug. In the case of this spark ignition engines. That completes our compression process. Now next process is called power stroke process or a expansion process. Now what happens in this is, already the spark is created with the help of a spark plug at the end of compression. Now because of that spark, the combustion happens in this expansion or the power stroke. So because of the combustion of that charge, it releases the heat energy, and that heat energy creates a force on the piston. It creates a force on the piston which will act as a driving energy for the piston and also the IC engine. Now because of that, now the piston is moving from TDC to BDC. It is moving from TDC to BDC, increasing its volume, which causes the expansion of the gases. Now at this point, what's the valve position? Both valves are closed. Now when the piston reaches the BDC, which completes the power stroke or the expansion stroke. Now the last stroke comes into picture here, that is exhaust process or exhaust stroke. So what happens here? Again, the piston will be moving from BDC to TDC. Now what is there in the combustion chamber now? We are having the gases which are released because of the combustion. Okay, now if the piston starts moving from BDC to TDC, exhaust valve will be opened and all the exhaust gases will be moving or will be escaping outside the engine, right? Now when the piston reaches again to the TDC point, exhaust valve will be closed and inlet valve will be open. So this is a sequence of operation or cycle of operations: continuous suction, compression, power stroke or expansion, and then exhaust. Now whenever a question was asked in the examination to write about the working of 4-stroke SI engine, means first we have to write the sequence of operations, that is suction, compression, expansion, exhaust, and we have to explain the each and every process by sketching the each process here. Okay, now what are the points we have to write? We have to write important 3 points. What are those 3 points? Here let's see. With respect to first point, we have to write with respect to piston. For suppose it is a suction stroke or an intake stroke. In this process, what is in which direction the piston is traveling? Piston is traveling from TDC to BDC. So that is the first point. Piston is traveling from TDC to BDC. That is the first point we have to write. And the next point what we have to write is with respect to the position of the valves, that is inlet valve or the exhaust valve. Now here inlet valve is open, exhaust valve is closed. That is the second point. Third point what we have to write? We have to write with respect to the charge. What happens to the charge? Charge will be entered into the cylinder. Charge, that is air fuel mixture, enters into the cylinder. So these are the important points compulsory we have to write in the examination for the suction stroke or the intakes process, right? What is the next one? Next one is the compression process or the compression stroke. Now here, during this process, in which direction the piston is traveling? Piston is traveling from BDC to TDC. Next point with respect to the valves, that is both valves are closed. Next with respect to the charge, what happens to the charge? Charge, pressure and temperature will be increased. Charge, pressure and temperature will be increased, and at the end of the compression process, the spark ignition, the spark is created inside the engine. That completes the compression stroke or a compression process. Now what is the next one? Next one is a power stroke or expansion. What happens in this with respect to piston? With respect to piston, the piston will be traveling from TDC to BDC. Now in this condition, both the valves are closed. And what happens to the charge? The charge at the end of compression, the spark is initiated, and now the combustion will be done. Because of that, heat energy will be released and piston will be moving down, and there will be a creation of the gases here, gases inside the cylinder. That is the with respect to the charge. Now what is the next one? Last one is exhaust process or the exhaust stroke. Now with respect to piston, in which direction the piston is traveling? The piston is traveling from BDC to TDC. Piston is traveling from BDC to TDC. With respect to valve position, inlet valve is closed, exhaust valve is open. Now gases will be escaping outside the engine, and when the piston reaches the TDC point, exhaust valve will be closed. Again, the inlet valve will be open. Now this is a working of 4-stroke SI engine. Now let us see a small animation video so that we can get a clear-cut idea how a engine works. Now here we we are saying that SI engine or a 4-stroke SI engine. What is meant by stroke here? Stroke is nothing but single travel of the piston. Now how many processes we are having? We are having 4: suction, compression, expansion and exhaust. To complete this 4, piston has to travel 4 times in between TDC and BDC, So which we call it as 4-stroke engine. Now let us start with the first process. Piston is traveling in the first process. Piston is traveling from TDC to BDC. Air fuel mixture is entering into the cylinder. Inlet valve is open, and when the piston reaches BDC, it is closed. Again, which completes the intake stroke or a suction stroke. That is first stroke. In the second stroke, piston will be moving from BDC to TDC, which when the piston reaches the TDC point, which completes the compression stroke. At the end of compression, a spark is created and combustion happens. And because of that, the piston tends to move towards the BDC. That is called combustion stroke or a expansion stroke. And next one is piston again moves from BDC to TDC and in that condition exhaust valve will be open. All the exhaust gases will be escaping outside the engine. So in this way all the 4 working happens: suction, compression, expansion and exhaust. Suction, compression, expansion and exhaust. So in this way all the 4 processes will be done in 4 strokes, that is 4 travels of the piston. Now comes to the working of compression ignition engine. Compression ignition engine. What is this compression ignition engine is? It is somewhat the same as the spark ignition engine, but the major difference here is it doesn't have any external aid to ignite the charge, but it will have a fuel injector. The remaining constructional details are the same. Now let's start with the first process, that is the intake stroke or the suction process. Now what happens in this process is piston will be moving from TDC to BDC. Piston will be moving from TDC to BDC. Okay. Now when it is moving from TDC to BDC, what happens inside the cylinder? First, initially a partial vacuum is created. Inside the cylinder, partial vacuum is created. When the partial vacuum is created, the pressure will be low than the outside. So when the inlet valve is open during intake stroke or suction stroke, piston will be traveling from TDC to BDC. Initially partial vacuum is created, then the inlet valve is open. When the inlet valve is open, now the air is drawn into the cylinder. Until which end? When the piston reaches BDC, the inlet valve will be closed and the entire cylinder, when the piston reaches here, the BDC, the entire cylinder is filled with the air particles. Entire cylinder is filled with the air particles. Now at this point, again piston starts to move from BDC to TDC. In that condition, inlet valve is closed, exhaust valve both are closed. Now piston is moving from BDC to TDC. The air which is present in the cylinder, because of the decrease in the cylinder volume, its pressure will be increases. Its pressure and temperature will be increases inside the cylinder. So when the pressure and temperature will be increases inside the cylinder, piston reaches to the TDC point at the end of compression stroke. When the piston reaches to the TDC point, the injector starts injecting the fuel at the end of compression, which completes the compression stroke. Now the next one, that is a power stroke or a combustion stroke. Now at the end of compression stroke, the fuel is injected into the cylinder. right? Now the fuel which is entered into the cylinder, it will be having a less temperature than the air particles here, than the air particles. That means the fuel will take the heat from the air particles continuously. Fuel will be taking the heat continuously from the air particles, so that the fuel will reach its self-ignition temperature. The fuel which is injected into the cylinder, it will reach its self-ignition temperature. What is the self-ignition temperature in the compression ignition engine fuel? Generally, we will be using the diesel as the fuel in the compression ignition engine, and that value will be 210 degree Celsius, 210 degree Celsius. So the fuel particle which is entered into the cylinder, it will be continuously absorbing the heat from the air particle. So when the fuel reaches its self-ignition temperature, it will start igniting itself. It will start, the fuel particle, it will start igniting itself. That means auto ignition happens at various spots in the combustion chamber, and because of that the heat energy will be generated, and the heat energy is used to move the piston downwards. That will act as a driving force here. That will act as a driving force. That will act as a driving force for the piston. And now the piston will be moving from TDC to BDC, TDC to BDC. That completes the power stroke or a combustion stroke. Now the last one is the exhaust stroke. Now what happens in the exhaust stroke? When the piston reaches to the BDC at the end of the combustion process or a power stroke, what happens here is the exhaust valve will be open. The exhaust valve will be open, and whatever the gases are released because of the combustion process will be escaping outside like this, will be going outside through the exhaust valve, and piston will be traveling from BDC to TDC, so that it will push the exhaust gases to leave the cylinder. Now when the piston reaches the TDC point, again exhaust valve closes, again inlet valve is open. Now this is a process happens in the working of compression ignition engines. So in this also, if a question asked to write about the working of compression ignition engine, means we have to write the sequence of operations, then we have to write each process diagram, and then we have to write the points. Okay, what are those points? Definitely we have to write with respect to piston, with respect to valve position, and also with respect to the charge, what is happening to the working fluid. Now this is a working of CI engine. Now let us see a small animation video. In this we can get a clear-cut idea how a CI engine works. Now here you can see the center at the cylinder head will attach a fuel injector. Now the working starts, that is intake or suction process. In this process, what happens? Piston will be moving from TDC to BDC. Piston will be moving from TDC to BDC, and at this point inlet valve will be opened with the help of a camshaft, whereas exhaust valve is closed. Now when the piston moves towards the BDC, initially I said no, there will be a partial vacuum will be created which causes a low pressure, and when the intake valve will open, the only air will be entered into the cylinder, and when the piston reaches to the BDC point, inlet valve is closed, and it is filled with, the cylinder is filled with the fresh air. Now the next process starts, that is a compression stroke. Now the piston will be moving from BDC to TDC, which causes the increase of pressure, that is air is being compressed, and at this point both the valves are closed. And air is not entering into the cylinder. Now air is being compressed, increasing its pressure as well as the temperature. Now after that, when the piston reaches the TDC point, the fuel injection happens with the help of a fuel injector. You can see there the fuel injection is happened. This is the end of the compression stroke. Next one is power stroke. When the fuel injection is done inside the cylinder, what happens? The fuel has to absorb the heat. Fuel has to absorb the heat from the air particles. Now see, these are the fuel particles. It is absorbing the heat from the air particles so that it will increase its temperature and reach a self-ignition temperature, and it will explode. It will explode at various points. Because of that explosion inside the engine, the heat energy will be developing. The heat energy is generated, and which impacts the force on the piston. This will be continued, and the piston will be moving from TDC to BDC. Piston will be moving from TDC to BDC, and both the valves are closed, and this energy will act as a driving energy for the piston and also for the IC engine. And when the piston reaches to the BDC point, BDC dead center, we will be having the gases. Next one is exhaust stroke. In the exhaust stroke, what we are having in the cylinder, we are having the gases which are at high pressure and high temperature. Now the piston will be moving from BDC to TDC with so many of gas elements like carbon dioxide, carbon monoxide, sulfur oxides, nitrous oxides, and hydrocarbon particles. So all these gases will be escaped out, and during this stroke the exhaust valve will be opened, intake valve will be closed. Now all the exhaust gases are leaving the cylinder, escaping out to the cylinder, and this is happened because of the piston is moving from BDC to TDC. Now that is completes the exhaust process, and this cycle again, when the exhaust valve is closed, again the intake valve will be opened. Only the air will be entered into the cylinder. This is how the compression ignition engine works. Now let us see the major differences or the comparison between the SI engine and a CI engine. SI means spark ignition engine, CI means compression ignition engine. The first one, it is based on the thermodynamic cycle. The spark ignition engine is based on what? It is based on Otto cycle. It is based on the Otto cycle, whereas the compression ignition engine, it is based on the diesel cycle. It is based on the diesel cycle. Now in the SI engines, the fuels what we use like petrol, it will have a self-ignition temperature, a high self-ignition temperature it will be having, a high self-ignition temperature. Now for the ignition of that fuel only, we will be using a separate external aid for the ignition purpose, that is called spark plug. So because of having high self-ignition temperature, we will be using this spark plug. And whereas in the case of CI engines, the self-ignition temperature of fuel will be less or low. Now what will be the value for the fuels what we use like petrol or the gasoline? It will have the self-ignition temperature of 250 degrees Celsius, whereas in the case of this self-ignition temperature of the diesel, already I said, that is 21 degrees Celsius, which is the temperature of the diesel in the spark ignition engine. Now with respective to the charge entry, that is in the SI engines, the air fuel mixture, the air and fuel charge will be inducted during suction stroke or the intake stroke into the cylinder. During suction process only, the air plus fuel will be entered, whereas in the case of CI engines, what happens? The air enters during the suction stroke, and the fuel is injected at the end of compression stroke. Now with respect to the throttling here, we can able to control the quantity of air fuel mixture introduced into the cylinder with the help of a throttling. That is, the air fuel mixture which is coming from the inlet valve, we can able to control that quantity with the help of a throttling process. Whereas in the case of CI engines, we cannot control the air which is entering into the cylinder, but we can control the quantity of fuel with the help of a fuel pump. With the help of a fuel pump, we can control the quantity of the fuel. Now coming to the next point of spark ignition engine, it is for the ignition of the charge. We need a separate ignition system. separate ignition system with spark plug for the purpose of the ignition. Whereas in the case of CI engines, a auto ignition occurs. Auto ignition occurs because already in the combustion process the temperature will be greater than the self ignition temperature of the diesel in the compression ignition engines. So definitely the auto ignition happens because of their compression ratios. Now next one is with respect to compression ratio. Compression ratio of SI engines will be ranging from 6 to 10, whereas compression ratio of compression ignition engines, it is ranges from 16 to 20. Why it is less for the SI engines and why it is more for the diesel engines? Because here if the SI engines are having more compression ratio, SI engines are having more compression ratio means inside the cylinder the pressure will be higher. Inside the cylinder the pressure will be higher. Pressure will be higher. When the pressure is higher, inside the cylinder, higher compression ratios leads to higher pressures. Higher compression ratios leads to high pressure in the cylinder. When there is a high pressure in the cylinder, in the SI engines, generally we will be using the gasoline as the fuel. Now, what the gasoline will do? Because of this high pressure, it will ignite itself before the normal combustion. So when it is ignited before the normal combustion, it leads to knocking. It leads to knocking. Because of that knocking, the damage of the system takes place and the efficiency will be decreased. So here, that is the reason for the SI engines the compression ratios will be less, and for the CI engine, we have to increase the temperature for the purpose of the ignition of the fuel which is injected. So for the compression ratio will be higher for the compression ignition engines, and because of the compression ratio is less, means size of the engine will be less. Because of that, the SI engines will be lighter in weight. SI engines will be lighter in weight, and when the compression ratios are higher, that means it is heavier in weight. And there will be thermal efficiencies also. There will be low thermal efficiency for the SI engine because of the less compression ratio, whereas here because of the high compression ratios there will be high thermal efficiencies. These are the major differences between spark ignition engine and the compression ignition engine. Now coming to the working of two-stroke engine. What is this two-stroke engine means? All the sequence of operation, that is suction, compression, expansion and exhaust, will be completed in two travels of the piston. When the piston moves only two times between TDC and BDC, all the four processes will be done. Then it is called two-stroke engine. So in this we will be having two strokes. The first one is upstroke, second one is a downstroke. Upstroke and the downstroke. And coming to the constructional details, it is somewhat similar as the four-stroke engine, but it doesn't have any valves and the valve actuating mechanisms. Then how the fuel will be or the charge will be entered into the cylinder, and how that after combustion, how the exhaust gases will be leaving the cylinder, means it will enter and exhaust with the help of the intake port here. With the help of this intake port, and the exhaust takes place with the help of the exhaust port. So in this two-stroke engines we will be having ports like intake port, exhaust port, and also the important one, it is the transfer port. So totally we will be having three ports: intake port, exhaust port and the transfer port. Okay, now let's get into the working of two-stroke engine. First, what is the first stroke? It is an upstroke. Upstroke means piston will be moving from bottom to top. Piston will be moving from bottom to top. Now for understanding this two-stroke engine, let us first, we have to assume that there is some air fuel mixture already present in the combustion chamber, already present in the combustion chamber. Now see, when the piston is moving from bottom to top, in the combustion chamber already the charge is there. What happens to that? Because of the compression, air and fuel mixture will be, pressure and temperature will be increasing inside the cylinder, that is above the piston. Now see, the piston, what it is doing, it is uncovers the whole of a intake port. This port is nothing but a hole. So it is uncovers the whole of a intake port, so that the air plus fuel mixture, it will enter into the crankcase. Because piston is uncovering the inlet port, and air plus fuel mixture will be entered into the crankcase. And above the piston, what is happening? Compression. Below the piston, intake is happening. And at this point, see, exhaust port is covered by the piston. Transfer port is also covered by the piston. This happens in the case of upstroke. Now, what is the end of upstroke? End of upstroke in the sense, piston reaches its topmost point and the spark is initiated. Okay. Now, in the downstroke, because of the spark initiation, the piston tends to move downwards from top to bottom. It moves from top to bottom. So, because of that, what happens here? First, piston will covers the intake port. See here, piston is covering the intake port, so that air fuel mixture will not enter into the crankcase. Now, that happens in the below the piston. Now, above the piston, what is happening? Already combustion is done in the previous process. So, because of the combustion, there will be the gases, right? That gases will move outside the engine through the exhaust port. Here the exhaust port is uncovered by the piston. So, exhaust port is open. So, from that, exhaust gases will be moving. That is from one side. In the opposite side, what is happening? Because of the piston movement towards downwards, the air fuel mixture which is present in the crankcase, it will try to enter into the transfer port, then it will enter into the main combustion chamber. So here, when the piston is moving down, first intake port will be closed, then whatever the gases are released because of the combustion in the previous process, those will be exhausted out, and in the opposite side, air fuel mixture from the crankcase, it will enter into the transfer port, then it will enter into the combustion chamber. So in this way, the intake, compression, combustion and the exhaust will be, 4 processes will be completed in 2 strokes of the piston. That is, in the upstroke. In the upstroke, what happens? Above the piston, compression takes place. Upstroke, above the piston, compression takes place. Below the piston, intake takes place. In the downstroke, what happens? After combustion, first exhaust takes place in the opposite side, and then fresh charge, it will enter into the combustion chamber through the transfer port. So in this way, the working of 2-stroke engine takes place. Now let us see a small animation video so that we can get in full working of the 2-stroke engine. Now in the step 1, the piston is moving up so that the space under the piston is enlarged here, and then intake port is open. Through the intake port, the air plus fuel mixture, it will be entered into the crankcase. It will enter into the crankcase. Then in the second process, when the piston moves downwards, this air plus fuel mixture will be entered the transfer port, then it will enter into the main combustion chamber. So main combustion chamber. Now in the next process, when the piston moves again upstroke, the air plus fuel mixture will be compressed above the piston. Below the piston, the air plus fuel mixture will be entered into the crankcase. Now at this point, what happens? Because of the compression above the piston, the air plus fuel mixture pressure and the temperature will be increases, and at that point a spark is created with the help of a spark plug here. A spark is created with the help of a spark plug. which initiates the combustion process. Spark is created with the help of a spark plug, which initiates the combustion process, and then combustion will be done. And when the piston moves downwards, first it will close the intake port, then the exhaust, whatever the gases are released, the exhaust gases are released, that exhaust gases are goes outside the engine through this exhaust port, right? Exhaust port is open, through that the exhaust gases will leave the cylinder, and from other side this air fuel mixture from the crankcase, it will be transferred to the combustion chamber. Now here one point is important, that is when the exhaust gases are leaving the cylinder from one side, the other side the fresh charge is entering. That is, this fresh charge will try to push the exhaust gases outside. That process is called scavenging process. That process is called what? Scavenging process. So scavenging process means the fresh charge is used to push the exhaust gases. That is called scavenging process. Now here you can see in the step 1 intake and compression happens. In the step 2 downward motion, combustion and exhaust happens. So this is the working of the two-stroke engine. Now let us see the differences between the two-stroke engine and the four-stroke engine. First one is the completion of the cycle. Now in the four-stroke engine, it takes 2 revolutions to complete that 4 different strokes: suction, compression and expansion, exhaust. To complete that, it takes 2 revolutions of the crankshaft. Here one stroke makes 180 degrees here. One stroke makes 180 degrees of the crankshaft. Now in the 4-stroke engine, how many strokes we are having? 4. So 4 strokes we are having. That means 4 into 180, which is called as what? 2 into 360. That means 2 revolutions of the crankshaft. The sequence of operation: suction, compression, expansion, exhaust will be completed in 2 revolutions of the crankshaft in the case of 4-stroke engine. Whereas here, how many revolutions? Only 1 revolutions, because it is 2 strokes. One stroke 180 degrees, the other stroke 180 degrees. So only 1 revolution here. So 1 revolution is enough to complete the 1 cycle of operations. Next, coming to the power stroke, for every 2 revolutions we will get only 1 power stroke. Whereas here, for every revolution we will get 1 power stroke. Now coming to the admission of the charge. In the 4-stroke engine, the charge enters directly into the cylinder. Whereas in the case of 2-stroke engine, first it will enter into the crankcase. Then it is transferred to the cylinder. That is the admission of charge. Next, with respect to valves and the ports, in the 4-stroke engine, we will be having the inlet valve and the exhaust valve. And to operate that inlet valve and exhaust valve, we need a valve actuating mechanism by means of a cam. So by means of a cam, we will be using the valve actuating mechanism. Whereas in the case of 2-stroke engine, we don't have any intake valve or exhaust valve, but we will be having what? Ports. The ports are opened and closed. It depends on the piston movement. In the case of 2-stroke engine, the ports opened and closed based on the piston movement, right? Now next one is with respect to cooling and lubrication. In the 4-stroke engine, it requires lesser cooling and lubrication, because for every 2 revolutions we are getting only 1 power stroke, whereas here for every 1 revolution we are getting 1 power stroke. That means we require a greater cooling and lubrication in the case of 2-stroke engines, whereas lesser cooling in the case of 4-stroke engines. Now fuel consumption is less in the case of 4-stroke engine. Fuel consumption is more in the 2-stroke engine. Now coming to the mechanical efficiency is less in the 4-stroke engine and it is more high in the 2-stroke engine. Why it is like that? Because we are having 4 different strokes: suction, compression, expansion and exhaust. Out of these four, only 1 stroke is power stroke, that is active stroke. Remaining 3 are ideal strokes. That means whatever the power is generated in the power stroke, active stroke, that is utilized for the remaining strokes. So some power is lost. That's why here the mechanical efficiency is less, whereas in the case of 2-stroke engine, for every revolution we are getting 1 power stroke. And that power stroke is well balanced in the next 2 strokes. So the mechanical efficiency is high, and because of the valve arrangement and the valve timing, valve actuating mechanism, the 4-stroke engine will be a heavy and bulking, whereas in the case of 2-stroke engine, it is heavy and bulky. In the case of 4-stroke engine, because of the valves arrangement and valve timing and valve actuating mechanism, and it doesn't have any extra valves or like that, so it is lighter and compact. So now coming to the summary, what we have discussed in the today's session is, we have discussed about the engine, classification of the engine, and then we have seen the applications of the IC engine, gas turbines, compressors, and we have seen the working of the 4-stroke SI engine, working of the compression ignition engine, and also the differences between the spark ignition engine and the compression ignition engine, and also we have seen the working of the 2-stroke engine and the major differences between the 4-stroke engine and the 2-stroke engine. Thank you all for watching this video.